A. What is A squared? So A squared plus BC, we know how to do matrix multiplication. We did a lot last time. AC plus CD. So what is trace of A? A plus D. What is trace of A squared? A squared plus D squared plus 2BC. So let us go to the star. Half A is A1 is A squared is A is equal to half trace A squared minus trace of A squared. Now that is half trace of A squared is A plus D squared minus trace of A squared, that is A squared plus D squared plus 2BC. That is half A squared plus 2AD plus D squared minus A squared minus B squared minus 2BC. Done. Now that was a routine checking. I want to carefully call out the names today. Yeah, I can go over that. Determinant of A is this. So A is this, A squared is this. That's routine. That is this. And so what is trace of A? Is trace of A is trace of A. Trace of A is A plus D. Last time we did a lot about trace. And what is trace of A squared? Some of the diagonals. That's there you go. And so from star, so by star, this is what we have. And then it's just routine multiplication, just routine calculation, that's all. Okay, now we are about to talk about an n by n matrix, the determinant of an n by n matrix. Determinant of an n by n matrix, but we'll come down to 3 by 3. So let A be a square matrix, be a n by n matrix. So first we need to introduce some notations, some definitions and notations. So A11, da 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 da, A1N, A21, da 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 da, A2N, AN1, da 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 da, ANN. Hmm? Okay, now So there is a typical element that is Aij. So you know what we do? Mij is the minor, and I have to explain to you what that means. Minor of Ai, which is what? Which is determinant of the matrix, the square matrix naturally, by eliminating ith row and jth column. I'm going to explain to you this thing with on the basis of a 3 by 3 matrix, you will see. And Cij will be minus 1 to the power 1i plus j mij. That's called the cofactor. So let's try to understand what does this mean. Let's take a 3 by 3 matrix best. A11, A12, A13, A21, A22, A23, A31, A32, A33. I'm going to write down the minors. So M11, it will be the minor of Aij. Now see how I'm doing it. I'm going to use my pen and follow my pen, okay? Everybody, follow my pen. I'm finding the minor of A11. So this is the minor of A11. So the minor of A11, that's what I'm going to find. Okay. Minor of A11, that's what I'm going to find. Do this, look here. A11 occurs in which row? First row. A11 occurs in which column? First column. Delete first row, first column. Take the determinant of this thing. If you delete this, can you see my pen, everybody, on the screen? If you delete this, what remains? This remains. So that is A22, A33 minus A23, A32. Let us write down all the minus, okay? M12, M13, M21, M22, M23, C21. No, so not so fast, not so fast. M31, M32, M33. Let's write down all the minus. So M12, so that means this guy goes in, this out, and you're left with A21, A33 minus A23, A31. There's the determinant, by the way, not signs are not coming. For A13, what will you do? This is out, this is out, this block will be A21, A32 minus A22, A31. M21, for M21, that means that is the minor of A21. Where does A21 occur? A21 occurs here. Here is it. So A22, A33 minus A23, A3. M22, A11, A33 minus A13, A3. M23, da, 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 da. A11, A32 minus A12, A31.
Professor,
Yes, please.
can you review again M21?
M21, okay.
Yes.
I'm doing it for you. M21 will be here. This goes away. This goes away. So my friend is very correct. A12, actually this was a typo. This is A1, A12, A33 minus A. Now I say, Professor, why can you do that? Yes, very good. A12, A33, A13, A3. M22, let's see, A11, A33 minus A31, A31. That's okay. M23, M23, A11, A32, A12, A31. Good. Now M31. Come to class on time. This is the online class. That's why you are getting this privilege. Anybody can is entering whenever, wherever. No, 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 no. Had it been classroom, I wouldn't have given you this privilege. Regular classroom sessions. But M31, let's see. This is distracting for me. Come to class on time. M31, A12, A23, A12, A23 minus A22, A1. M32, A11, A23 minus A13, A21. Thank you, that's okay. And M33, A11, A22 minus A12. M33, na? M33. This A11, A22, A12, A21. Let me double check M32. That's why I get distracted. Don't. A11, A23, is A13, A12. Yeah, that's right. So this is the whole story of minors. These are the minors. And the cofactors. So let us take a particular example. Let us take, suppose, A. Okay, remember, cofactors are what? Cofactors will be Cij, will be minus 1 to the power I plus j, A minus. They are the respective cofactors. Now, I will show you, okay. Okay, now these are the, let me take an example. Let's take an example. An example will be good. I want to find out, what I want to find out is something called the adjoint of a determinant. And I will tell you why that is so interesting and important. But first, let us take an example. Let's take A to be 3, 1, 0, minus 2, minus 4, 3, 5, 4, minus 2. Let us write down all the minors. Come on. M11 is what? Quick, do it with me. Quick, do it with me. 8 minus 12. M12. I'm going to write all this in one line. So M12 minus 6. M13. Did I get it right? M12? Ah, exactly, minus 11. Thank you. You're right. Absolutely correct. Because 4 minus, no, 4 minus 15 minus 11. M13. M13. So minus 8 minus 20. Minus 8 plus 20. Well, now all of you will be checking with me, okay, please? Why is it minus 20? Why is it, she's saying minus 20. Let's see. This goes away, this goes away. Hello, my friend, look here. This goes, this goes. This is the block. Minus 8 minus 20. Okay? Minus 8 minus 20. Okay. M1, M21 minus 2. M22 minus 6. M23. M23. This goes away, this goes away. This goes away, this goes away. 12 minus 5, 7. M31. For M23, okay, let's see. There is a problem with M23, somebody is saying. This goes away, this goes away. 12 minus 5. I don't understand. Yeah, 12 minus 5. Okay. Okay, M31. This goes away, this goes away. 3. M32. This goes away, this goes away. 9. M33. Minus 12. Minus 12 minus 2. Minus 12 plus 2. Now let us write down the cofactors. Now let us write down the cofactors. Let's write down the cofactors. C11, it is minus 1 to the power of I plus 2. No? So minus 1 to the power 2. So minus 4. C12. C13. C21. C22. Minus 1 to the power 4. It is 1 times 6. Okay. Now, let us go back to the one by to the. Let us go back to. No, let us do it here. I want to show you something. How will I find the determinant of A? Determinant of A. How many rows are there? 3 rows. How many columns are there? 3 columns. The idea is we can expand along any row. We can expand along any column. We can expand along any row. We can expand along any column. So it is for so it is A1J C one J plus dot 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 okay no for it let me write in the formula for an n by n matrix for an n by n matrix A1J C1J plus dot 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 ANJ CN. Cofactor expansion, this is the cofactor expansion along jth column. Which is the same as AI1 CI1 plus dot 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 AIN CIN. This is the cofactor expansion along ith row. So that's the general situation. So that means I have, if A is A11, A12, A13, A21, A22, A23, A31, A32, A33. If this is my A, then determinant of A, look, cofactor expansion along the first row. So A11 C11 plus A12 C12 plus A13 C13, which is the same as I can do it any rows. Cofactor expansion along second row, cofactor expansion along third row. So that is A21 C21 plus A22 C22 plus A23 C23. That is A31 C31 plus A32 C32 plus. No, yes, they will give the same determinants. Exactly. Thank you. These are things that we will prove later. And now do it along the column. Say, I'm just showing you one. A11 C11 plus A21 C21 plus A31 C3 and etc. So that's the way you find determinant of A. That's the quickest way. Now let me go back to my matrix here. And this is the problem of using IPAN. I have to write it again. The A was 3, 1, 0, minus 2, minus 4, 3, 5, 4, minus 2. Determinant of A. I want to find the determinant of A. Let us do it along the first row. That's the easiest one. A11, C11 plus A12. First row, we are doing C12 plus A13, C13. So that is equal to 3 times C11 is minus 4 plus 1 times C12 is 11. Oh, why don't you try two of them? Just two. I'm giving you, asking you to try two. So number one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Find determinant of A. Number 2, minus 2, 1, 3, 6, 0, 5, minus 1, 2, 9. Find determinant. Do them. You must, and I leave it to you. Cofactor expansion along anything, but let us just do it along the first row. It's okay. You will see that it's quick. So that you don't have to find, if you want to find the determinant, you don't have to find all the cofactors. If you choose the first row and then you find, okay, first row, just the cofactors on the first row of the elements of the first row. Do this to let's see. Just practicing. The choice is for you make the choice, right? Whether it is the first row, first column, second row, second column, whatever. So what is the determinant? What's number one? Determinant is zero? Really? Okay, let's see. 1 times 45 minus, I think you are right. 36 minus 42. Yes, she is right. Determinant of is zero. So a matrix, remember, a square matrix A whose determinant is zero This 0 is called singular. A inverse exists if and only if A is non-singular. That is, determinant of A is not 0. And what is number 2? Number 2, what's the answer for number 2? -54 -5. Is this what you're getting? Please tell me. Yeah, is this what you got? You got -3. Right? You got -3. Let's see. People are getting all funny answers. Let's see. -2. I'm doing it along the first row, okay? -2 times -10, yes. +1 times 6 nines are 45. And 6 nines are 54. 9 6 54, right? Yeah, 54. 54 minus 5. Oh my God. Good. Wait. This is easy to make mistakes. 54 minus 5. 54 plus 5. Then -3 times 12. That's fine. So this should be 59. How come it doesn't match with anybody's result? 79 minus 36. This is 43. Where was the -3 from? Plus minus plus. Oh, plus minus plus. Okay. So this is, wait. Things are going wrong here. Let's see, plus 59. Let's see. I see what has happened. Plus minus plus. So this is minus and this is plus. So this is 20 minus 59 plus 36. So that is, our friend was absolutely correct. Very good. Very good. This is an attentive class. Do one more and then we can hop off to the next question. 3 minus 6 minus 7, 1, 5, 10, minus 2, 6, 4. Find determinant of Good. This is an attentive plus. So determinant of A plus minus plus 3 times 20 minus 60 plus minus 4 minus minus 20. 4 minus minus 20 plus minus plus 6 minus minus 10.
Professor, is not negative 6
Huh?
or like 3 times negative 40, negative 6 times
Please
24?
check the noise. Then there should be no noise.
Oh,
There is too much noise there. No, I will check. 3 times, yes. 4 times 5, 20. 20 minus 60. That is right. Negative plus minus plus. Minus minus 6. 4 minus minus 20. That's right. Minus 7. 6 minus minus 10. So what's the problem? Hmm? Yeah, that is what I think we are going to get. 144 minus 120 is 24, and that is minus 88. Okay, so that's fine. Before we take a short break, I have three good problems. First, number one, find lambda such that determinant of A is 0. A is lambda minus 2, 1, minus 5, lambda plus 4. Number 2, find lambda such that determinant of A is 0. And A is lambda minus 4, 0, 0, 0, lambda 2, 0, 3, lambda minus 1. Let A be A, B, 0, C, and B be D, E, 0, F. These two matrices. Prove that AB equal to BA if and only if the determinant B A minus E, E, D minus F is C. Good. Let's do this. And then we will take a break and then we will finish the rest of the class. Let's do this. And these three. And do number one. Numbers 1 and 2 should be quick. Maybe I will help you on number 3. Yeah, number 2. 3 we will do it together. Numbers 1 and 2 should be quick. You do these problems. Meanwhile, I would like to call out the names. Everybody should try to be on the screen. It's very important, actually. It's in your interest. Abu Bakr Akhtar. I can see the person there, but I cannot see him. And no audio, no video. Abu Bakr Akhtar, are you present? Abu Bakr Akhtar, are you present? I'm going to put the board up, but before that I have to. Abu Bakr Akhtar, are you present? Hmm? I have to come back to this guy. Hugo Barahona. Good. Caesar Becerril. Thank you. Timothy Boyce.
I'm here.
Timothy Boyce? Oh, thank
I'm
you.
here.
Okay, thank you. Nathaniel Campos. Nathaniel Campos. Nathaniel Campos. Marked absent. Amit Charan.
Here.
Okay, thank you. Ricky Chen.
Here.
Victoria Cortes.
Mic on.
Here.
Okay. Erin Desir.
I'm here, Professor. Good
Thank
afternoon.
you. Thank you. Stephen Dorwell.
I'm here, Professor.
Anjali Dutt.
I'm here, Professor.
Thank you. Matthew Esposito.
Here.
Sebastian Francois. Samuel Huang. Samuel Huang. Samuel Huang. Samuel Huang marked absent. Jean Bart Sebastian. Thank you. Orly Evans Joseph. Yes, I can see. Yes, thank you, sir. Mohammed Kabir. Mohammed Kabir. Mohammed Kabir marked absent. Lindita.
Here.
Thank you. I can see you. Shania Khan. Thank you.
Yeah.
Wasif Khan. Wasif Khan. Wasif Khan marked absent. Shakila Khatun.
Here, Professor. I'm here.
Thank you. Thank you. Stanley Lee.
Here.
Simon Lowe.
Here.
Thank you. Yun Kong Ma.
Here.
David Mejia.
Here.
Where?
I'm wearing a green shirt.
Very good. Green shirt. Anyway, David Mejia. Fine. Michael Meneses.
Here.
Okay. Ariel Moskowitz.
Here.
Thank you. Stephen Ola.
Here.
Yeah. James Nung. Good. Nazia Nusha.
Here.
John Pulley. John Pulley. John Pulley, out. Sean Ramlal. So this is 16318.
Yeah, that's me.
Could you please change that 16318 next time?
Yeah, I think I have to leave and then come back in to change it.
No, not today. Next time. Next time.
Okay. Yeah, next time I got you.
Next time.
Thank you.
Thank you. Eddie Santos. Eddie Santos. Mana Sebastian. Hey, Mana Sebastian. Abdul Tani.
Here.
Abdul Tani. Where? Where is Abdul Tani?
Here.
Oh, thank you, thank you, thank you. Alex, you?
I'm right here.
Good. Nathaniel Campos.
I'm here, sir. I'm not on my laptop. I'm on my desktop, which doesn't have a camera. But my laptop, which I'll be using for exams, does have a camera.
Okay, good. Samuel Huang. Mohammed Kabir, you came late.
No, I was here. I got disconnected. I'm sorry.
Oh, okay. Samuel Huang. John Pulley. Eddie Santos. Mana Sebastian. Okay, good. Very good. Let us go back to our sharing. Okay, so the first problem should be very easy, no? Determinant A. Oh, see, the problem is lambda minus 2, 1, minus 5, lambda plus 4. Determinant of A is 0. Determinant of A is 0 implies lambda minus 2 times lambda plus 4 minus 5 plus 5 is 0. Lambda squared minus 2 lambda plus 4 lambda plus 2 lambda minus 8 plus 5 is 0. Lambda squared plus 2 lambda minus 3 is 0. Lambda plus 3 times lambda minus 1 is 0. And that implies lambda equal to 1 or minus 3. Got this? Number 2. Determinant of A is 0. So lambda minus 4 times lambda minus 1 minus 6 is 0, 0. That also, yes, that's it. So lambda minus 4 times lambda squared minus lambda minus 6 is. So lambda minus 4 times lambda minus 3, lambda plus 2 is 0. That implies lambda equal to minus 2, 3, or 4. Number 3. A is AB 0C. B is DE 0F. So AB equal to BA, they're saying AB is what? AB 0C that gives you AD plus BF 0. No. AD plus B times 0, sorry. AD plus B times 0. 0 times D plus C times this is 0. AE plus BF. 0 times E plus CF. And BA DE 0F AB 0C B times A plus A times 0 AD 0 BD plus CE 0 CF. Now you see, so AB equal to BA implies what? AE plus BF is equal to BD plus CE. Okay, they're saying if and only if. Now the determinant B A minus E D minus F is 0 implies what? B D minus B F minus A E I. This cannot be. This cannot be. Wait a second. This cannot be. There must be a typo somewhere. B A minus B A minus C. Yeah, there you go. Minus C. So E D minus F, very good. So wait a second. So E minus C. Yeah. So BD minus BF minus AE plus CE is 0. And that's exactly this. I mean, from star. Oh no, okay, don't do that. That implies AE plus BF is equal to BD plus CE. Call this equation 1 and 2. Compare. So I'll simply write 1 and plus. Okay, now what we are going to do, we will focus on 3 by 3 matrix only for the rest of this class. We will do two important things. One method of finding the inverse of a 3 by 3 matrix, and the second will be Cramer's rule, which is very much about 3 equations and 3 variables. And then Thursday, we must prove them. We should prove them. So you take 7 minutes break, not more than that. Just take 7 minutes break. It's 2:43 now. 7 minutes. So we start at 2:50. Stanley Lee, you're joining the meeting now. I mean, oh, okay, fine. Okay, let us come back. This is the theorem that we are going to prove on Thursday. This is the theorem that we are going to prove on Thursday. Suppose A is an n by n matrix, which is non-singular, that means determinant is non-zero. Then the inverse of A is 1 upon determinant of A times adjoint of A. And what is adjoint of A? A is this matrix. You take the matrix of the cofactors. This is the matrix of the cofactors. Take the transpose of this matrix. That's called the adjoint of A. So let us go back to this question. Example, very important. Find A inverse if A is 3, 2, minus 1, 1, 6, 3, 2, minus 4, 0. First, find the matrix of the cofactors. Very important. No, first find the determinant. If the determinant is 0, sorry, inverse doesn't exist. So determinant of A is 3 times 0 minus minus 12 minus 2 times 0 minus 6 plus minus plus minus 1 times minus 4 minus 4 minus 12 minus 4 minus 12 minus 6 36 plus 12 plus 16 64. So not 0. So A is non-singular. Therefore, A inverse exists. Okay, now find the matrix of the cofactors. That means you have to do it very carefully. Matrix of the cofactors. Now, when you do the matrix of the cofactors, you see, you have to be careful about the signs. How are the signs going? So remember, signs are like this. Cij is minus 1 to the power I plus j mij, where mij is the minor, right? So plus, minus, plus, minus, plus, minus, plus, minus, plus. I find it very useful to write it like this. So find the matrix of the cofactors. Matrix of the cofactors, remember. So 0 minus minus 12. So that is 12 with the positive sign. Correct me if I make any mistakes, okay? That's for you to check also. You do it with me. 0 minus 6, that is minus 6 with a negative sign. Minus 4 minus 12 is minus 16. Zero minus minus 4. 0 minus 4. That is minus 4 with a negative sign. 0 minus minus 2. That is 2. Minus 12 minus 4 minus 16 with a negative sign. 6 minus minus 6, 12. Nine minus minus 1, 9 plus 1, 10 with a negative sign. 18 minus 2, 16. That's the matrix of the cofactors. Then what is the adjoint of it? Take the transpose. So what is the inverse? So that is 12 upon 64, 4 upon 64, 12 upon 64, 6 upon 64, 2 upon 64, minus 10 upon 64, minus 16 upon 64, 16 upon 64, 16 upon 64. We will prove this theorem later on Thursday. Okay, this is how you find, this is one method of one quick method of finding the inverse. Why don't you do this? Now, all of you, I give you 10 minutes time. Find the inverse. Yeah. I don't think I will be able to get into Kramer's rule today, but anyway, at least I will just give you a hint. Let's see. 2 by 5 minus 1. Okay, do these two. Let's see. Take your time. Yeah, I give you 15 minutes time. First, let us check whether number the determinants. Whether the determinants determinant A two yes. That's not so. The number one determinant of A is -6 plus 15 minus 10. Ah, that's nice. -1. So that's good news. And number two determinant of A. You see, in number two, look at this. Look at this. If you expand along the first, yeah, you can expand along the first column. So you see 2 times 2. Then plus minus plus minus. Minus 0 times something plus 0. So the determinant is 4. You check along the first column, you see, you get the same thing. 2 times 2 plus minus plus 3 times 0 plus minus plus 0. Yeah, 4. So very good. In both cases, A inverse will exist. Now you will tell me, you will find the A inverse. Quick. So we will do Kramer's rule on, yeah, first Thursday we will do that. So I want to find the matrix of the cofactors, right? So plus, minus, plus, minus, plus, minus, plus, minus, plus. So matrix of cofactors. So as I do, please check also, right? Your result, please. -3. -3 with a negative sign, 3. -4 minus -2. -4 plus 2. 15 minus 20 minus 5. 6 minus 10. 6 minus 10 minus 4. 8 minus 10 minus 2. 0 minus minus 5. I 0 minus minus 5. 0 minus minus 5 plus 5. Minus 2 minus minus 5. Minus 2 plus 5. Did all of you get this? Can you please tell me, did all of you get this? Adjoint A will be the transpose of this. And what is the A inverse? Well, here the determinant is minus 1. Did all of you get this? That's the A inverse. Oh. Let's do this and then we can end today's discussion. 2 minus 3, 5, 0, 1, minus 3, 0, 0, 2. We already saw that the determinant of A is 4. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So matrix of cofactors. Do it very carefully. Two, what happened? 2, okay, so just 2. Plus minus 0. 0. Minus 6 with a negative sign. Yeah. 4. 0. 9 minus 5, 4. Aye. Minus 6. 2. So what's the adjoint? Adjoint of A so what is A inverse? 1 upon 4. Huh? Any questions, anybody? Let me just give you some practice, fine homework. So that I will start with Kramer's rule on Thursday. Fine. A inverse. Take say take this two. All right, so I'll stop here. So what I will do is then I don't want to push into Kramer's rule because there's much to say there. So we will first go over these two quickly. I hope both of them are non-singular. Let's check. In number one, determinant of A is 2 times minus 12 plus minus plus minus minus 6, minus minus 6. Oh my goodness, this is 0. So A inverse does not exist. B and E means does not exist. And number two, determinant of A oh, this is good. So this is your homework. Well, why homework? We can finish it now, right? Let's finish it. Come on. So that there will be no homework, we will go straight to Kramer's rule. Find A inverse in number two. So matrix of cofactors. Come on. 6. 48 negative, the negative. 24 minus minus 5, no? 24 plus 5, 29. Six with the negative sign. Remember? This goes away, this goes 0, 0. This goes away, this goes 2. So the determinant was what? 12. So what is the adjoint of A? It's the transpose of this. So A inverse is 1 upon determinant times this, no? Determinant is 12. So 1 upon 12. Okay. That's the end of today's discussion. Any questions so far? So listen, there will be, I got determinants minus 13. Why? How? No, it cannot be. 2 times 6. It's clear. Expand along the first row. Just expand along the first row. It's impossible. 2 times 6 minus 0. So, I told you there will be 2 exams. So, 2 exams, 2 in-class exams. Or in-class means this is online exams. Plus, I'll make it 3 quizzes. So I will give you a quiz next week. I will tell you tomorrow, this Thursday. And it will be very simple. Quiz means just say 20 minutes. So I will ask you to find an A inverse and 1 question Cramer's rule. That will be good for you. That will help you. We will talk about this on Thursday. Okay. Any questions?
Professor, do you mean instead of 2 exams, you're going to give 3 quizzes?
No, not quiz. We will not have quiz this Thursday. I will talk about the quiz.
No, I mean instead of exam.
No, not instead of the exam. I said the 2 exams plus 3 quizzes.
Oh, okay.
Not the plus. Okay, I will tell you about that on Thursday. Any questions? Any questions, anybody? Good, then I'm ending the meeting and I will
The
say.
date for the exams.
Huh?
See you on Thursday.